Welcome back. Today I'm covering the second section of Chapter 10, dealing with liquids. So today's learning objectives: describe the motion of particles in liquids and properties of liquids according to the kinetic molecular theory, and then discuss the process by which liquids can change into a gas, basically define what vaporization is, and then finally talk about the other direction where liquids become a solid, basically define freezing. So liquids form a matter that has a definite volume and takes the shape of its container. So we have intermolecular forces going on here that do determine the properties of it. Particles are still in constant motion, but they're closer together. We have attractive forces that are a little bit more effective. And if you remember from our intermolecular forces, dipole-dipole, we have basically opposite charges, slight dipole-dipole, like a positive attracted to a negative. We have London dispersion, which is very similar to dipole-dipole, but it happens a lot in nonpolar molecules, as well as hydrogen bonds. So liquids are more ordered than gases. Okay, they're not bound in fixed positions, but they do move constantly, and they're more ordered because they're closer together. They also have relatively high densities due to their closer particle arrangement and can form layers. So, you can say milk is less dense than maple syrup, which is less dense than corn syrup, than honey. They also have some solids in here, but just focus on the liquids. Relative incompressibility. Molecules that are closely spaced are not easily compressible as they were with gases. So, you had that, I showed that short little clip about how you can store a large amount of oxygen in a container for scuba diving. But over here with liquids, that's not the case. Okay. The ability to diffuse, in which it can also dissolve. So diffusion is slower due to the attractive forces and proximity of molecules. So if I drop a dye in water and just not stir it, just let it mix on its own, eventually it will become purple, or the entire beaker will become the color of that dye. If I were to increase the temperature of this solution, then the diffusion rate also increases because particles are moving faster as you increase in temperature. But eventually it will reach equilibrium. Okay, another unique property with liquids is called surface tension, a force that tends to pull adjacent parts of a liquid surface together, thereby decreasing the surface area to the smallest possible size. So they're pulling on each other, and you get a nice little water droplet. This is where I would probably give you guys pennies and give you rubbing alcohol and water and count how many drops of rubbing alcohol you can put on a penny before it spills over, how many drops of water on a penny before it spills over, and talk a little bit about surface tension and the attractive forces found in alcohol versus water. But surface tension is also responsible for water bugs and how they can stride or walk on the surface of water. Okay, and so you can break that surface tension by disrupting the intermolecular forces that are occurring between each particle of water. You find surface tension, especially in small tubes. We call this capillary action, attraction of a surface to a liquid to the surface of a solid. So here we have liquid surface together, so adjacent parts, so liquid to liquid. And here with capillary action, we have liquid to solid. And you kind of see that it climbs up the side of this tube here, so we call this a meniscus. So surface tension and capillary action occurring. The smaller in diameter your tube is, the more that liquid can actually climb up it, and this is how plants they move water from their roots up to the tops of the plant.
Capillary action is the attraction of a molecule on the surface of a liquid to the molecules of the surface of a solid. Because of capillary action, liquid moves up this very narrow capillary tube. When fluid flows up a tiny tube or piece of paper, it is the result of the attraction between the liquid and the surface of the solid, combined with the liquid's surface tension. The liquid will rise until its weight balances the pull of gravity. The same process is responsible in part for the transport of water from a plant's roots up to its leaves.
Okay, Evaporation occurs in liquids, so particles escape from the surface of a non-boiling liquid, and they enter the gas state. Now, this is also known as vaporization. In your book, list evaporation first and vaporization as kind of like a sub part of it. Really, vaporization should be up here, and evaporation and boiling should be underneath it. Vaporization includes evaporation and boiling. So that, evaporation is not the same thing as boiling. Boiling is where it occurs throughout the entire liquid. So this diagram, I think, does a great job showing vaporization when a liquid or gas changes to a gas. Where here we have evaporation, it takes place at the surface. And here we have boiling, when a liquid changes to a gas below the surface as well as above it. Formation of solids, also known as freezing. So liquid becomes a solid. We lose heat as this occurs. So liquid particles cool. Its average kinetic energy decreases to the point where attractive forces pull the particles into an even more orderly arrangement, aka becoming a solid. So when a solid becomes a liquid, we're adding energy to it, it melts. Okay, the particles become looser, they flow and glide past each other. You increase that energy, eventually it could evaporate or boil or vaporize, depending on what you want to look at. With gases, if you remove energy, it cools and condenses into a liquid. Remove even more energy and it solidifies into a solid. So that does it for liquids. Tomorrow we'll talk about the properties of solids. So you should probably finish your 10.2 worksheet. That's due tomorrow by 3:30.